Okay, so welcome to chapter 6. This chapter is primarily about polygons, specifically about quadrilaterals, so four-sided polygons, and all the different ways we can classify them. The first section deals with, as it says, angles of polygons. So we're going to be talking about working with the angles within a polygon. We've already classified and named them. We did that back in chapter 1, and now we're bringing it back again for chapter 6. So the two things we're going to do is find and use the sum of the measures of the interior angles of a polygon and the sum of the measures of the exterior angles of a polygon. So the first thing we have to bring up is the definition of diagonal. Now, a diagonal of a polygon is a segment that connects any two non-consecutive vertices. So P and T are considered consecutive vertices, and I don't connect them. Well, if I do, I can. I don't consider it a diagonal because if I connect them, it's a side. So P is not next to T. I mean, it's not next to S or R. So there's one diagonal. There's another diagonal. Okay, and then from P to Q, that's one diagonal that does, or one segment that doesn't count because it's next to it, or it's consecutive, or the one next to it. So here we go. First question: how many triangles? Okay, so here's the first key to what we're working with in the beginning of chapter 6 in section 6.1. If I take any four-sided figure, we've already talked about this. We know it has 360 degrees. And the reason we know that is if I draw one diagonal, this triangle's 180, this triangle's 180. Now, if I take like a five-sided figure, okay, if I take a five-sided figure, I can draw a diagonal to here, another diagonal here, and now I get 180, 180, 180. So 180 plus 180 plus 180, that's 540 degrees. If I take a hexagon, okay, and start at one point and draw on all the diagonals from that one point, I get one triangle, two triangle, three triangles, four triangles. So again, 180, 180, 180, 180. And that gives me 1, 2, 3, 4, which is 720 degrees. Okay, so here's the deal. There's a pattern here. 4 sides is 2 triangles, 5 sides is 3 triangles, 6 sides is 4 triangles. So you're going to have a couple questions come up here. So for, let's say, 7 sides equals how many triangles? For 8 sides equals how many triangles? And then the last question is going to be some unknown number of n sides equals how many triangles? Okay. Okay, we're back. So hopefully you realize the pattern pretty quickly that if you have 4 sides, that's 2 triangles. If you have 5 sides, 3 triangles. If you have 6 sides, 4 triangles. So it's always 2 less than the number of sides. So 7 sides, well, 2 sides less is 5 sides, 5 triangles. 8 sides, 2 sides less is 6 triangles. Now here's the important part. If I don't know the number of sides, I call it n, I want 2 less, that means I want n minus 2 triangles. And now here leads us to the formula for this section. So when I had 4 triangles, for the degrees, it was 2 times 180. For 5 sides, it was 3 triangles times 180. For 6 sides, it was 4 triangles times 180. Okay. So for 7 sides, 5 triangles times 180. 6 sides times 180. N minus 2 sides times 180. And what I've just figured out is a formula to figure out how many degrees there are inside any polygon given its specific number of sides. So theorem 6.1, the polygon interior angle sum theorem. The sum of the interior angle measures of an n-sided polygon, and the key is convex, which all these are going to be convex, so we don't have to worry about that, is always n minus 2 times 180. So the drawing here, the example, they have a pentagon, so it's 5 angles. So 5 minus 2, which is 3 triangles, 3 times 180, 540. Okay, so here's our first example. Find the sum of the interior angles of a convex nonagon. So the first thing I have to do is I have my formula. Interior angles sum equals n minus 2 times 180. Well, a nonagon has 9 sides. And really, the big thing for this section is you've got to have these shapes memorized, the names. It's in the book here, but you got to have those memorized. So, interior angle sum is 9 minus 2 times 180. Whoops. Interior angle sum equals 7 times 180, which equals then 1260. No. Yeah, 1260. There we go. So if I took all 9 of those angles, added them up, I get 1,260 degrees. Okay. Now here's another example of actually how we kind of apply this. Now I know we already know this, but I picked this one because of the fact that we do already know it, so it's easy to kind of sort out. It's a quadrilateral. I know all 4 angles have to add to 360. But how we could do this if it weren't a quadrilateral is I can say, okay, I've got this formula, n minus 2 times 180 degrees. So let me plug in then the number of sides. Well, it's 4. So 2 times 180 is 360 degrees. So there we go. I would know that there's 360 degrees on the inside. Now to solve for x, 360 is 10x plus 6x plus 6x plus 3x minus 15. Okay. So 10x plus 6x plus 6x plus 3x, that ends up being 16, 22x, 25x. Add 15 to both sides, 375 equals 25x. Divide by 25. 15 equals x. Oops, sorry, I ran out of space there. So x is 15. Okay, now, next example. Find the measure of each angle of a regular decagon. So this one's actually asking us to do a couple of things. So what we're going to do is we're going to figure out each interior angle of a regular decagon. Well, what we have to realize is that if it's a decagon, it equals 10 sides. So, and then it means 10 angles. Oh, I can't type today. The first question is, what does regular mean though? Okay, so hopefully you said that regular means all sides and angles congruent. So what that means for us is if I can figure out the sum of the interior angles, just divide by 10, because that's how many angles there would be, that would give me 1. So, interior angle sum is 10 minus 2 times 180. That gives us 8 times 180. Which is equal to 800 plus 640, 1440. But that is 10 angles. So divide 1440 by n, 1 angle equals, or by 10 I mean, 1440 divided by 10, 144 degrees. Now there's more to interior angles in this, but that's enough for the video for this. The next thing we're going to do is switch to exterior angles. Okay, so exterior angles. Now, exterior or outside, and remember we define them as being linear pairs with an interior angle. Now the key to this is, even though if I draw a shape, I have an exterior angle here, and I could draw the other side over here and talk about this exterior angle. What we're talking about here is not 2 exterior angles, but just 1 for each angle. So this angle 1 here, call this one angle 2, call this one angle 3, all 3 of those. Same thing for this square, you could have 1, 2, 3, 4. Okay. So every shape has, if it has 4 interior, it has 4 exterior, because we just count the same one next to it. Now this is actually equilateral and equiangular, meaning each angle is 60 degrees. And this is a square, which means each angle is 90 degrees. Okay. Now, here's the thing. The exterior angle is a linear pair with the interior, so they're supplementary. So if this is 60, this guy here is 120. Same thing here, 120. Same thing here, 120. Well, let's add up all the outside. 120 plus 120 plus 120. $360. Okay, now let's see if there's a pattern for this guy here that builds off of this like we had before. Well, these again are all linear pairs, so if this is 90, 90, 90, 90, 90. So 90 plus 90 plus 90 plus 90. 90 plus, oh, that's 360. Hey, look at that. They're the same. And actually, it's always the same. So exterior angles are actually really, really nice. Their sum is always the exact same, 360. Unlike the interior, which changes depending upon what the interior angle is. Okay. So, theorem 6.2, the exterior angle measures of a convex polygon, one angle at each vertex, is 360. And notice I threw that 1 in there because, again, if we double the number of exterior angles, if we did 2 off of each angle, it would give us twice this at 720. So we're just doing 1 for each vertex angle. Okay, so I got a series of questions here for you. Okay, so hopefully that was kind of tedious, and now that last theorem is stuck in your brain. Next question then. Find the measure of each exterior angle of a regular decagon. Okay. Well, this is pretty easy because the exterior angle sum is 360 degrees. We already said, hey, a regular decagon has all the angles congruent. So it's 10 angles that sum to 360. So one angle equals 360 divided by 10. Whoops, not 210, 10, which is 36 degrees. Okay, so for homework for tomorrow, we've got this weird kind of almost, I like to think of these like as throwing stars when they all go that direction, like a weird throwing star shape. So your job is to solve for x for this figure here. And then in class we'll talk more about section 6.1.